All right, let's talk about Rust. For years now, it's been crowned the most loved programming language. But what if I told you its real superpower, the thing that really makes it special, isn't actually in the code itself? It's a single strategic decision that changed everything. I mean, we all know about Rust's famous memory safety and its incredible performance, right? But is that the whole story? Not even close. You see, the real secret to its success lies somewhere else. It's in the chaotic, frustrating world it was designed to fix. So, to really understand why developers love Rust so much, we have to jump in a time machine. We need to go back and look at the world of systems programming in C and C++. A world of incredible power, sure, but also a world of incredible daily pain. This constant tooling friction was like a tax on your brain power. Imagine spending half your day not writing code, but just trying to get your project to build. You're fighting these cryptic error messages that have absolutely nothing to do with your actual logic. This wasn't a weird, rare bug. For a lot of people, this was just the normal cost of doing business. And right at the heart of all that friction was this notorious monster called dependency hell. Seriously, this wasn't some minor issue. It was a daily, project-killing nightmare. And one of the most common traps it would set for developers was something called the diamond dependency problem. So here's how it goes down. Your app, it needs two other libraries. Let's call them A and B. Simple enough, right? Well, library A needs an old version of some common tool, libfoo, but library B needs the new version. And guess what? A program can only use one version. So you're stuck. The build just breaks, and now you're stuck untangling a mess that you didn't even create. And, on top of dependency hell, you had to navigate the build system labyrinth. There was just no single standard way to build a project. Every time you joined a new team or started a new project, you basically had to learn a completely different set of tools and arcane rules. This constant churn is just a perfect example of incidental complexity. It's all the work that has absolutely nothing to do with solving the actual problem. Okay, so the creators of Rust, they lived through this chaos. They knew this pain firsthand. And when they sat down to design a new language, they made a decision that would change everything. They decided to solve these tooling problems from day one. This one question was pretty much the guiding star for Rust. The core idea was that raw power and a great developer experience shouldn't be opposites. You could have both. You should have both. And the key to making that happen was a really pivotal insight. And here it is. Tooling isn't an afterthought. It's a first-class citizen. Right from the very beginning, Rust was designed not just as a compiler, but as a complete, integrated development platform where the tools were just as important as the language syntax itself. Just look at this table. It shows the whole paradigm shift in a nutshell. On one side, you've got the old world, fragmented, manual, and just waiting to cause an error. And on the other, you have Rust's answer, a centralized, automated, and unified solution for every single one of those pain points. This is that philosophy in action. This integrated solution is basically embodied by the hero of our story, Cargo. Cargo is the command line tool that sits at the absolute center of the Rust developer experience. You can think of Cargo as wearing 3 different hats, and they all work together perfectly. It manages all your dependencies, it orchestrates the entire build process, and it sets really clear conventions for how every single Rust project should be structured. Let's see how it tackles dependency hell first. This two-file system is the cure. It's genius. In a file called cargo.toml, you just list the libraries you want to use. Then, the first time you build, Cargo goes out, figures out all the exact versions that play nicely together, and saves them in cargo.lock. From that point on, every single person who works on that project gets the exact same dependencies. That classic, well, it works on my machine problem, yeah, that's gone. And then there's the universality. This is huge. It doesn't matter if you're on Windows, Mac OS, or Linux. The commands are always the same. Cargo test always runs your tests. Cargo build -release always creates an optimized build. This kind of consistency was absolutely revolutionary for systems programming. Now, Cargo is the engine, right? But every engine needs fuel, and that fuel is the second half of Rust's integrated solution, its official package registry, crates.io. So you can stop hunting for libraries on random websites or forgotten GitHub repos. Crates.io is the single source of truth. Every published version of a library is permanent and can't be changed, which provides this incredible foundation of stability and trust for the entire ecosystem. And this right here is where it all clicks together. Want to use a library you found? One command. Want to share your own amazing library with the entire world? Just one command. This radical simplicity completely changes the game. It encourages developers to share small, focused libraries, which leads to a way more modular and healthy ecosystem. So when you combine Cargo's frictionless tooling with the central library of crates.io, something really powerful starts to happen. You create a self- and reinforcing cycle, a kind of positive feedback loop. We can call this the community flywheel. Because it's so easy to publish, more people share their code. Because there's a central registry, that code is super easy to find and use. Because there's a rich library ecosystem, more developers are attracted to Rust. And guess what? Those new developers publish more code, which just speeds up the whole cycle. This is the engine behind Rust's explosive growth. And this really gets to the heart of Rust's superpower. The entire ecosystem is designed to relentlessly hunt down and eliminate incidental complexity. By clearing away all that frustrating friction with the tooling, it lets developers focus their limited brain power on the essential complexity, the actual problem they're being paid to solve. And ultimately, that is the superpower. By providing this batteries-included experience right out of the box, Rust acts as this incredible democratizing force. It creates a gentle on-ramp into the really complex world of systems programming, making it more approachable, more productive, and honestly, more enjoyable for developers coming from any background. So that brings us to a final thought. What's really more important, the language itself or the ecosystem around it? I think Rust's story proves that a great language just isn't enough anymore. Investing in the developer experience, it's not a luxury, it's a core feature that can absolutely define whether a language succeeds or fails. Thanks for joining us.